Hi everyone, welcome to my YouTube channel. So in the video today we will be solving a DSA question in which we have to move all the zeros from the arrays to the end while maintaining the relative position of all the non-zeros number. So basically uh, we have to move these numbers, these zeros in the end. So in each of the case, in the example, we can see the zeros are moved to end, and then the relative positioning of non-zero number is maintained. And if there is no zero number, then it will remain the way it is. So we will be solving using two part. In the first part, we will check each of the numbers, like in each of the array, we can just choose. So in each of the array, we will look into the number. If it is 0, then it will be moved to the last of the array. If it is non-zero, then it will simply take the counter, which would be initialized at 0. So basically, our algorithm will look into each number. So it will. So for example, if in the first example we have 7 digit, so it is 5430120. So we will start with we will do the enumerate of these numbers. So it will be kind of it will count as first, second, third, fourth, fifth, sixth, and seventh. So for each of these numbers, what it will do is it will start checking for the numbers. Like it will start with the first, and it will see if this is number is whether this number is 0 or not equal to 0. Accordingly it will keep this number. So for example, if it is non-zero, it will keep at 4 5. Then if it is this is non-zero, it will keep at 4, right? It will remain at 3. Now coming to this number, when it is 0, so what it will do is it will not keep any number on this. Rather it will go to the next number, and the next number will be this 1. So it will pick 1, and then it will pick 2, and then so the basically the numbers would be 1 2 3 4 5. So out of 7, we have this 5 number in this order. Now what in the second part of the solution, what we will do is we will look into the length of the array, and length of array minus length of non-zero numbers would be the would be would be the length where we will add all zero. So it will be the remaining of the remaining of the positions in the array, which we will allocate as 0. So we will provide 0 to all the remaining number. So let's look at the code to understand it in a better way. So this is we will start clearing the terminal. So in the first part, what we are doing is we are looking at length of the array, uh, which will be which will be important for us to evaluate the number of non-zeros number, and as well as the number of zeros, right? So once we have the length, first we have to look at the edge case. So uh, we can have a case where we can get only one digit array, right? So in that case, we simply need to return the array as it is. So we will simply return our array, right? Now going to the other part. Now in the case where we don't have we have the number as 2 or more than 2, we have to start with initializing the counter. We will initialize at 0, and once we initialize, we have to iterate through each element using enumerate. So the advantage of enumerate is like it will help us to maintain the relative order of all the digits within the array. So for example, we will just highlight idx, and the value will be the number, the digits which we have in each of the array, right? So this is we once we have we can go over the loop within the array. So if the value is not 0, we will move it to the position indicated by counter and increment counter by 1. So in this, what we will do is we will simply check if value is not equals to 0, then array for counter equals to value, right? And once we do it, we have to just increment the value of counter by 1. So this is done, right? Now, so this is how we can process all the non-zeros number. Now, once we have all the non-zeros number, we have to look into the remaining numbers. So these will be, this should be 0 in our case, right? So this counter will move on until we have the value of counter equal to the value of length of the array, right? So we'll use while loop. So while counter is less than length, then what it will do is it will simply take counter as 0, right? And then it will add counter, and in the end it will return the array, right? So try to understand the algorithm. What we did is we started ruling out the edge case where the length can be less than 2. In that case, we simply want the array the way it is, right? In the second case, we started with initializing counter as 0, and then we enumerate the array with the index value and the value of the digits, right? And then we iterate through each of these elements and to check whether it is 0 or not. In the case it is not 0, what we'll do is we'll simply take the array and the counter value starting from 0, and we will allocate that index to the value which is non-zero, and we will simply add the counter, right? In case of the array where we don't have any zeros, these counter plus 0 would stop at the maximum value of the enumerate, right? But in case where there are some zeros value, what it the counter will, even after the finish of this operation, the counter will remain less than the length of the array. So in that case, what we will do is we will go to second while loop, where array will again start with the counter where this operation would stop. So this counter will take it as 0. So array will allocate that counter as 0, and it will further add it until until and unless when the length, uh, the counter equates to the length of the array, it will go on, and it will allocate 0. And once we are done with everything, we are simply returning array. So let's check if it is working or not. So for array, we have to allocate, let's give it 1, 2, 3, 4, 0, 0, 9, right? So let's print move zeros to end array, right? Now if we run the function python move zeros dot py, so you can see the output is like all the zeros are moved to the end. We can also check in case where we don't have any zeros. So for example, if it is 3 5, it should be the way it is, right? Yeah. So we have to save it. Sorry. Now again, if we run this code, then we are getting, yeah. So this is running perfectly. So yeah, that was it for today's video. Thanks for watching.